Okay, this will be the Chapter 6 problem child review problems. So let's get right into it here. So number one here, they kind of give you a table. So a discrete distribution, values could be 1, 2, 3, 4, or 5. And we are trying to figure out what are the chances that that the value is 5. So this one, again, it's just one of those rules. If all the probabilities in a discrete distribution, or any actually, they need to add up to 1. So you kind of just have one missing piece there. So you can kind of add those up and subtract from 1, and you should get the answer of B, 0.2 for number 1. Okay, so that would take you to number 9. I'm just going to go through in order here, actually go through to number 2. Okay, so let's take a look. Number 2 is, let's see here. Same kind of situation, except they're asking a different question. What is the probability that the value is less than or equal to 3? So all we need to do there is add up the probabilities of those corresponding values, adding up 0.05 plus 0.2 plus 0.3 should get us an answer of 0.55, so that answer is A. Okay, so let's move on to number 3. Okay, number 3, weights of a dog at a pet store. Here's the key here, normal distribution. Okay, that's going back, we did in chapter 2, I think it was. But it's still one of the things, it's one of the continuous distributions, so it's a big one for us. They give us a mean, they give us a standard deviation. We're trying to find a probability of something being in between two numbers, so if you think visually, okay, it's normal bell shape, we know the mean is 12, and they're asking, what are the chances that this dog's weight is in between 10 and 12? So we're finding an area, okay, and we're just thinking of it as a probability again. So it's kind of saying, what percentage of the 100% or the full area is 1 under there? How much of it did we shade? Okay, so since it's normal, we can do a normal CDF, cumulative, right? Because we're including everything in between 10 and 12. And actually, when we use normal, we use CDF all the time. Unlike binomial, which we'll see in a few minutes, we use the PDF sometimes. So there's a difference. We'll talk about that. But for this one, it's cumulative. It's all the area in between 10 and 12. Those are your left and right boundaries. The mean was given and the standard deviation was given. Okay, so we should be able to throw that in and get an answer of around 0.112 for that one. Okay. Okay. All right, moving along. Number 4. Two friends play golf. We have their mean score. We have their standard deviation. So I want to know, what is the standard deviation of their differences? Okay, so basically, how many does one guy usually win by? What's the standard deviation of that? So the key here is we first need to go to variances. So you might want to make another row here. The variance is just the standard deviation squared. So in this case, they're nice, easy whole numbers. Okay, so the variance of their scores are 36 and 64. So the difference in those, the key thing you remember here, variances always add. Okay, so we don't want to do a subtraction problem. And it seems like you should do that, but they always will be added. So even though it's a difference problem, we're going to add the variances. Okay, that would be the variance of the difference. Now we need the standard deviation, so to get back to standard deviation, like to go from here to here, we squared it. So to get back, we need to do the square root. Okay, so this problem boils down to the square root of 100, which ends up being 10. Okay, so answer C for that problem. Okay, moving on to number 5. Find the mean and standard deviation of this distribution. Now there's ways to do this by hand. I'm going to encourage you to use the calculator. What you're going to want to do, put the x values in list 1 and the y values in list 2 right next to each other. And we're going to use one variable stats here. And the way we're going to get these numbers quickest is to go to one variable stats. Okay, and we actually want to make sure both of these sets of data are important to us. the x values and the probabilities of x. So we need to make sure after you do one variable stats, you have to tell it L1 and L2, so it knows to use both. It'll know that this is like a table with x values and probability values. And then it will give you the mean as x bar. I believe this one was 3.5. And the standard deviation, this one should have been 1.2. Okay, so those will be right in the list as soon as you press enter on the one variable stats. So this one is option A. Okay, moving on to number 6. Let's get that ink out of here. Okay, random selection of a batch of 300 iPads is being selected. The probability that an individual iPad works is 0.95. If we select 5, what is the probability that they all work? Okay, so this is binomial. It's not talking about getting your first success. It's having a set number of successes. Okay, so the reason they gave you the 300 and the 5, okay, there's one thing you got to check. Remember the rule was in order for this 0.95 to remain constant throughout, the population size has to be at least 10 times bigger than the sample size. Okay, because if it's not, imagine if there was only like 10 iPads and we're taking 5 of them. Every time we take one out, it changes the probability for success each time. But since there are 300 of them, and we're only taking 5 out, it's reasonable to assume that that probability will stay about 0.95. So just kind of check that out. But in this case, we can use the binomial. You very may well see a problem where you can't, though. So you got to check that condition of 10 times bigger than the sample. But in this case, we're good. So we want 5 successes out of 5 trials. Okay, that's the chance that they all work. So all 5 work. So again, we have 5 total trials. The probability for each one is 0.95, and they use K or they might use X. I can't remember. I've seen different variables used, but we want 5 successes. Okay, so the quickest way to do this on the calculator, this is a binomial PDF. Okay, we are not adding up a bunch of individual probabilities. We're finding the chance of getting exactly 5. Okay, so we're going to go out of 5, 0.95, 5 successes, and this one should give you an answer of 0.774. Okay, so B. Okay, moving on to number 7. There we go. Similar situation here, 300 iPads. The probability that an individual is defective is 0.05. If we select 6, what is the probability that 2 or more are defective? Okay, so this one, think about the random variable is the number of defective. Okay, so out of 6. So I like to draw myself a little table even. I think it helps to think about this. Okay, so could have 0 defective, could be 1, could be 2, could be 3, 4. Okay, and there's a probability that we get each one of these. These are my x values. There's a probability, there's some chance that I get 0 defective. Okay, that number would go here. There's some chance that I get 1 defective, and so on. Our question is asking, what are the chances that we get 2 or more defective? So it's basically asking us to add up each of these numbers. The chance of getting 2, that's some number, plus 3. Okay, so the one option is to go and do a bunch of individual problems like the problem we just did. Okay, and you could go and do one for 2, do one for 3, do one for 4, and add them all up, and that's fine. There's a quicker way, though, and that's using the fact that all of these probabilities, including these two, all have to add up to 1. Okay, and there's a shortcut on the calculator to find these two right here, the green two, the 0 or the 1. That's using the cumulative density function, the binomial. So what I would do in this case is I would say the green stuff is binomial CDF. Remember, C stands for cumulative because we're adding up more than one together. Now that's everything up to 1. So it's a similar order. There's still 6 things, there's still a 0.05 chance, and we want to go up through 1. We don't want to include 2 here. okay? Um, and then to get our final answer, what we would need to do is take 1 minus that, and that would give you all of the red ones that we want would be 2 or more. Okay, so it's 1 minus the binomial CDF. That will give you the chance that it's 2 or more. Okay, and this one should turn out to be 0.0328. Okay, so D was the answer there. And I would suggest even writing out this table the way I started this. To me, it really helps to see it. You know, sometimes it's kind of confusing. Do we use 1 there? Do we use 2 there? And if you have the table written out, you can see like exactly which ones you want. Remember, anytime you're doing cumulative, it's going to take you up to that number and add up everything below it. Okay, so in this case, we only want it to go up to 1. Okay, number 8. Again, back to the golfers. What is the probability that their combined score, so the sum of their scores, um, is more than 175? Okay, so what we know, okay, we're going to assume it follows a normal distribution. They probably should tell us something about that. But what we know for their combined score, we know the average can just be simply found by adding the two means together. Okay, so in this case it's 178. That's their average when they go out and play. They average a 178 combined. Okay, now the standard deviation of this, I think this was an earlier problem. We use these two numbers again, so we're going to go 6 squared plus 8 squared. Remember, change them to variances and take the square root of it. And I think we ended up getting 10 for that on the previous problem. So that's the standard deviation for their combined score. Okay, and so what this is boiling down to is again, of being above 175, so wherever that would be, I'm asking myself, what are the chances that it's above 175? If we know the mean's 178, and we know the standard deviation's 10, it's just a normal CDF problem. Okay, so I'm just going to go norm CDF. Okay, again, always cumulative with the normal, unless you're making a graph, which we really don't do. But our boundaries on this one, we want to start at 175. I want to go up, I'm just going to put a big upper bound, and we're going to use the mean, and then the 10 will be the standard deviation of this. Okay, and that should end up giving you an answer of about 0.618. Okay, so about 62% of the time, they will score more than 175 combined. Okay, number 9. So which of the following is not a condition for discrete? So the sum of the probabilities is 1, that's true. X can take on any value within an interval. That's actually the answer, but let's go through the other ones. Each probability must be between 0 and 1, that's always true. There are a countable number of X values. That's true for discrete. Okay, remember you can make a table, like the ones we've seen with the iPads and the ones with the I can't remember what the first two examples were, but the ones that have a table, those are discrete. Option B is the one that's not true. That's true for continuous. That's like the normal bell-shaped curve. It can take on any value within an interval. So those are measurements more. Discretes are more counts. Okay. So B is the answer to that one. And finally, the last question, number 10. Back to the iPads. The probability that an individual iPad is defective is 0.05. If we select until, you get a defective one, okay? Until your first success, that's geometric. Okay, remember that's the only difference with geometric, or there's actually a couple differences. The geometric is until your first success, and there is not a set number of trials because you don't know how long it's going to take until you get your first success. Okay, so this one's saying what are the chances it takes you 5 or more? Okay, so again, think about the table. Okay, you could get in your first attempt, second, third, fourth, fifth, sixth, seventh. Okay, and it's going to keep going on here. And again, these are the number of draws until you get a defective one. Okay, there's some chance that you get a defective one on your first attempt. That number would go here. There's a chance you get it on your second attempt. That would go there, and so on. So this question is asking 5 or more attempts. So it's saying add up everything from 5 and up. Add each one of those up. It takes 5, takes 6, takes 7, anything more than that. Okay, so this is another one similar to the previous problem. Since it's a more than problem, I'm going to use um, a, a cumulative density function. I'm going to find out what are the sum of the first four. Okay, that's geometric cumulative density function because we're adding up a bunch of individual ones. And this one, again, we're going only up through 4. We're not including 5. And the probability for success is 0.05. Okay, so remember, we're calling getting a defective one is a success. Okay, so that number on your calculator will be the chance that it's 4 or less. So in order to get the ones we want in red here, we would just need to subtract that from 1. So it would end up actually being 1 minus that. And that should give you an answer of 0.8145. Okay, and that's the problem trail. Here's a summary of the answers if you wanted to check and make sure you were in the right order and everything. If you started with number 1, you should go through in that order.